Chemistry Quality Control, Calibration and Reportable Range Final Quiz by Tarek Hammam.
السلام عليكم ورحمة الله وبركاته. رجعت لكم مرة تانية في فيديو جديد. الفيديو السابق كنا ناقشنا فيه Calibration Verification والريبورتابل رينج والبروفيشنسي تيستنج. الفيديو بتاعنا ده عبارة عن فاينل كويز على الفيديو السابق، وفضلا وليس امرا ان انتوا تعملوا لايك وشير وسبسكرايب عشان الفيديو بتاعنا يقدر يوصل لاكبر عدد من الزملاء يقدروا يستفيدوا بيه باذن الله تعالى، وشكرا جزيلا لحضراتكم.
A medical laboratory scientist has installed a new urine drug screen on her immunoassay analyzer. What should be her starting assumption about the frequency of running control samples? Please select the single best answer. 1 QC samples must be run at least daily. 2 QC samples should be run monthly. 3 QC samples that span the range of the assay must be performed during the initial validation, but then afterward, only as needed. 4 QC samples should be run with every batch of patient testing. The correct answer. The minimum requirement for QC is daily testing. Manufacturers will outline the specific number of controls and may require more controls to be run than is typical. Monthly QC is rarely permitted by manufacturers of non-point-of-care assays and should not be a starting assumption. QC that challenges the range of an assay, or the clinical decision point range of assay, is not a bad idea, but it is not usually part of an initial validation. Instead, patient samples, not QC, that span the range are used to compare the new assay. Running QC with every batch of patient testing, such as with every rack, is sometimes required but is quite rare due to the inefficiency and the cost that such frequent QC would require. Batched QC should not be a starting assumption. Daily QC is the most typical frequency, is the CLIA minimum, and is the starting assumption. A medical laboratory scientist working in a toxicology laboratory is looking for controls for a urine oxycodone assay. The cutoff for the assay is set at 100 nanograms per milliliter. Which set of controls would be best for the daily QC of this assay? Please select the single best answer. 1 positive equals 300 nanograms per milliliter, negative equals 0 nanograms per milliliter. 2 positive equals 1000 nanograms per milliliter, negative equals 0 nanograms per milliliter. 3 positive equals 115 nanograms per milliliter, negative equals 85 nanograms per milliliter. 4 positive equals 150 nanograms per milliliter, negative equals 50 nanograms per milliliter. The correct answer. All assays need controls, even qualitative assays. Of the options given, a positive control of 115 nanograms per milliliter and a negative control of 85 nanograms per milliliter are the best options. These controls are 15% above and below the assay cutoff and so will adequately assess the medical decision point of the assay and more sensitively reveal any performance issues with the assay or instrument. Using controls that are within 20% of the assay cutoff is the common rule of thumb for such assays. Using QC that is within 15% is even better, and more robust than 20% since it will reveal analytical issues with the assay sooner and with more sensitivity. A medical laboratory scientist, MLS, receives a package of proficiency testing, PT, samples for her laboratory's serum protein electrophoresis test. Which of the following should be avoided? Please select the single best answer. 1. The samples should be run with patients on the same gel. 2. The samples should be randomized to whichever MLS is working the bench at the time the samples are tested. 3. The PT samples should be interpreted by the same people who read and report patient specimens. 4. The PT samples should be run in duplicate, ideally in another facility. It is imperative that PT specimens not be sent to another address or facility. PT samples should only be run in duplicate if that is how patient samples are normally analyzed. All attempts should be made to run PT samples exactly as patient samples are run. They should not be processed, tested, or interpreted differently or by alternate personnel. A hospital had a plumbing issue that resulted in water flooding the floor of the laboratory. As a result, a large chemistry analyzer was unplugged and moved to another room. After building repairs are made and the instrument is returned to its original location, what should be performed? Please select the single best answer. 1. Assays on the instrument should be recalibrated. 2. 10 days of QC should be run to re-establish QC means. 3. The instrument vendor should come and check the instrument before powering it back up. 4. Patient samples should be performed in duplicate for the first 8 hours or so. The answer. Calibration is required when there is a reagent lot change, QC fails to meet established criteria, or after major instrument maintenance or movement. Moving the instrument would likely qualify as a major change to the instrument, and so recalibration would be appropriate. It is not necessary to re-establish QC means or run patients in duplicate. And while an instrument vendor may offer to assist with a move, they are not necessarily required to be part of redeploying an instrument that was shut down or moved. A medical laboratory scientist is asked to perform a linearity check on an AST assay that is being validated in the laboratory. Which of the following is true? Please select the single best answer. 1. Linearity is the same as a calibration verification if the assay is known to be linear. 2. If 5 to 7 days of QC results are plotted, linearity can be verified. 3. Running samples with concentrations spanning the assay's range can determine the linearity. 4. Linearity verification is no longer required for any FDA-approved assay. The answer. A check of linearity simply verifies that the assay is linear and not curved, and is often done as part of an initial validation. Linearity is not the same as calibration verification. One cannot assess linearity using QC. It is not true that verification of linearity is never required for an assay. A manufacturer may require such a check, and most validations will perform a linearity study and report a correlation coefficient, R2, that describes how linear the assay response is. Which of the following is the testing of materials that have known concentrations in order to substantiate an instrument's calibration? Please select the single best answer. 1. A linearity check. 2. An analytical measurement range, AMR, study. 3. Calibration verification. 4. Between-day precision. The answer. Calibration verification refers to the testing of materials of known concentration in the same manner as patient samples in order to substantiate the instrument or test system's calibration across the reportable range of patient test results. A linearity check assesses the correlation or straightness of an assay. An AMR study validates, or revalidates, the linearity and accuracy of the assay over the range of the assay. Between-day precision is an assessment of QC values across different days. Which of terms below is closest in meaning and practical use for the term AMR? Please select the single best answer. 1. QC mean. 2. Linearity. 3. Calibration. 4. Recovery. The answer. Although not the same thing, the AMR will reflect the linearity of the assay. An AMR analysis requires a linear regression and assessment of the linearity of the assay, with the expectation that the assay is indeed linear over the measuring range of the assay. The other terms are not as directly related to an AMR study. The QC mean is just the average of the latest QC values, it does not address the range of the assay. Calibration obviously impacts the performance of the assay and sets the characteristics of the assay's range, but calibrating or recalibrating resets the relationship between instrument signal and expected concentration. It does not specifically assess the range of analyte concentrations for a given assay. Recovery studies involve the addition of a known amount of analyte to a sample and then determining what % of the amount added is detected.